So far, we've only been using a straight line to fit the data. So does that mean we could only use straight lines for a hypothesis? Well, the answer is no. It's time to buckle up because things are about to get curvy. Now, take a look at this dataset. It's clear that a straight line won't cut it here. It's like trying to fit a square peg into a round hole. We need something more flexible. So we would like to end up with a hypothesis that looks more like this. This is what we call polynomial regression. Here we embrace higher-order features to capture the intricacies of our data. For example, we could try to fit a quadratic function through the training set. But if we look closer to this, the price of the car would go down again if the amount of horsepower goes up even further. So maybe we could even look at a third-order polynomial. For example, like this one. As you see, this fits the training data way better and it will result in more accurate predictions once the model is trained. But wait, how do we go about fitting a polynomial model through this wavy data? It's actually not that difficult. We can do this through the machinery of multivariate regression. For example, if we assume we need this third-order polynomial to fit the data, then we can just map the higher-order terms of the feature x into the features x1, x2, and x3. Now we get this hypothesis that is familiar to us. We can just use it as we did before. So we can train the parameters as we did before using gradient descent, resulting in the parameters theta that fit best through the data. After our parameters are trained, we have a model that can make predictions on new unseen input data. But here's the plot twist. In the case of polynomial regression, feature scaling becomes really important. It's not too hard to see that our ranges of the different features are very different. Assume that x1 has values between 20 and 1000, then x2 has values between 400 and 1 million and x3 has values between 8000 and 1 billion. If you forgot how you could scale your features or you haven't watched this video yet, I recommend that you check out this video on the channel. Now, brace yourself for a mind-blowing move. Square roots. Yup, you heard it right. We can even take the square root of our features and fit them through the data. It's like adding another layer of sophistication to our model. And guess what? We're not even limited to the features handed to us on a silver platter. We can create our own features, molding models as complex as our hearts desire. It's like being the architect of your own data universe. For example, assume you want to predict something based on the length, the depth, and the height of a house. We know that we could multiply these parts to obtain the volume of the house. Meaning that it is just as valid to make your own feature x, which is the volume of the house. This gives us following hypothesis, and if we train it, it might even be a better model than if we would have trained the original hypothesis with the 3 different features. However, this is not always the case. This is up to you to test both models and see for yourself. Now, I get it. This might sound very overwhelming. Which features should I take? There are so many different possibilities. Don't worry, though. Soon, we'll unravel algorithms that choose the right features for you. It's like having a personal assistant for your machine learning endeavors. So, stick around because the journey is just getting started. Hit that like button, subscribe if you haven't already, and let's keep this machine learning adventure rolling.